previous video of this series, we learned how to write your very first Solidity Smart Contract, primitive data types, functions, mappings, events, modifiers, constructors, and all the good stuff and everything that you need to know to write your very first contract. Today, we're going to be going over how to test your very first smart contract. My name's Anthony, and with the Blockchain Dojo, where we teach you how to be a blockchain ninja and a Solidity expert. If you like what you watch and you learn something new, please like and subscribe for more content. Let's get started. In today's tutorial, we're going to be going over how to test your smart contracts. This would include testing for desired outcomes, fail cases, and events emitted, and things along those lines. We're going to be testing our smart contract using the hard hat framework with the Mocha testing library. Let's get started. In the previous video, we went over the storage contract and how to write it. We went over the primitive data types, enums, mapping, structs, events, modifiers, functions, constructors, and all the other good stuff there. Today, we're going to be testing that smart contract. So in the Mocha framework, it works by writing tests within these describe functions. And within the describe block, you have a few different options you can call. The it keyword actually runs a specific test, while the before each keyword actually runs this code prior to each one of these it checks. In this contract, the first thing that we did is we described the storage contract, declared the storage variables, the deployer, the user, and users, and then entered in a before each. Before each statement runs before each one of these it statements. And what it does is it assigns the deployer, user, and users to the await ethers get signatures, which returns an array of 10 different hard hat Ethereum account addresses. Next, what we do is we declare the storage contract and await the contract deployment, passing in the testing string, which is the required variable within the constructor over here. Next, the first thing that I like to do in every single smart contract is do a smoke test to make sure that it's working properly. And what we do is we check that the owner is the deployer. Within the Mocha framework, how you do a test is you use expects or assertions. What the expect does is this expects that this return value of storage contract.owner is equal to the deployer's address. The next test we're going to run is we're going to check that the initial storage string was actually set within the constructor. So if we remember over here in the constructor, when we deploy the contract, we pass in this test starting string, which testing string is equal to, you guessed it, testing string. What this does is we are testing this constructor functionality to ensure that this starting string is in fact stored with the storage string variable. Next, what we do is we check if the contract is live. Remember with enums are a representation of a value. So when we get the status over here, contract status up at the top, this is checking on what the status is, whether it's live or paused. With enums, live would equal 0 and pause would equal 1. So what we do is we expect that the storage contract status is equal to 0. Next, we check that the number of updates is equal to 1, since when we initially deploy this contract, we are updating the storage string one time right here with this number of updates variable. What I did next for this contract is I wrote another describe block. So what this describe block is going to do is going to pause and unpause the functions, or test the pause and unpaused functions and fail cases. What's interesting is that I wrote this describe block within another describe block. So what happens is this before each statement is still triggered for all of the tests within here. But now I also wrote a second before each in order to pause the contract. So what we do first is we do the before each to pause the contract. Then we want to check that the storage contract status is equal to 1, which, if you remember, is the enum status of paused. Next, we want to check that the contract is in fact paused, which was where we checked its enum status. Next, we want to check that the pause modifier is actually kicking in. And with this, what we do is we actually, instead of testing for something to be equal to, we test for the functions to be reverted with. And what's interesting about this is we can actually test that not only will the function calls be reverted, but what the specific reverted reasoning is. And then next, the last thing we checked in this describe block is we checked that the status was unpaused. This is ensuring that this function and this function are still working and that the modifiers are still. In the next describe block, we tested the global variable storage functions. So in the first test, we checked that the global storage string variable is updated to test, which right here we connect user2 to update the string to test. Then we expect that the storage contract get storage string function returns the test string. And then next, we also want to check that the storage contract number of updates is equal to 2, since we did update the contract a second time, the first time being, of course, within the constructor. Second, what we want to do is we want to check the delete function. So we want to make sure that the storage, typo here, we want to make sure that the storage string is deleted and set to an empty string. So that's what we do first. We connect user3, we delete the string, and then we expect the wait storage string to equal an empty string. The next describe block, what we did is we went over the user's storage string mapping functions. So that's these functions down here, which interact with the function or with the struct and with the mappings. So the first thing we want to do is we want to check that the user1 struct was created, in which we connect to user1 to the storage contract, set the user variable to storage string, and then an arbitrary value of 10, since those are the two variables needed to pass in. Then what we do is we get a reference to the user1 struct by calling the storage contract get user storage user1.address, which is this function right here, passing in user1's address, which returns a struct. Next, we test the struct and then the variables within the struct, specifically the storage string to equal test string, and the user1 struct to equal the arbitrary amount value. Next, we check that the struct was deleted. So we await the connect user1, delete user variable, and then the user1 struct is await. We grab a reference to the user1 struct by awaiting the storage contract get user variable and passing in the user1 address. Then what we do is same as we did to the previous test, is we want to check that the user1 struct storage string is equal to an empty string and that the arbitrary value is equal to 0. From there, we also want to test the events that are emitted. So in order to do so, we do an expect await storage contract, we connect user2, and then we set the user variable, which is in the user mapping, to the string of test2 with an arbitrary value of 10. And then we do .toAdmit, and then we use the event name, and then we can do .with args to actually check that the event is emitting the correct arguments. And then we, of course, do that same thing when we delete the storage variable to ensure that the correct event is emitted with the correct arguments being user2 address and the empty string. Okay, now we've written all the tests. What do we do next? The next is pretty simple. We want to run the test and make sure everything passes as expected. So in order to do this, what we do is we run npx hardhat test, and then boom, it runs the check on all the tests. As you can see, this storage contract, pause and unpause functions, global storage variables, those are the describe blocks, while these green checks here are the it blocks, actually checking that each one of these tests have passed. So the big question is, why do we test our smart contracts? It's fairly simple. Something that I cover very frequently here on this channel is there are a lot of vulnerabilities and exploits that happen here in the blockchain and DeFi space. Testing your smart contracts is a very simple way to ensure that you get the proper outcomes from the function calls that you want, and to ensure that you're getting the proper fail cases and access controls triggered, as well as events emitted. Once a contract is deployed on the blockchain, it's immutable. It means you cannot change the code, you cannot work out any bugs. So if you have millions of dollars held within a smart contract and find out that there is an exploit where someone can drain it, you're up the creek without a paddle, to say the least. So that's why we test these smart contracts, to take in every account that we can to ensure that the contract is as secure as possible. Thanks for watching to the end. I hope you guys learned something new today about how to test your smart contracts and the importance of testing smart contracts. If you did learn something new, please like and subscribe, and stay tuned for more content.